Hello everyone, welcome back to my channel. In today's video, we are going to understand the ROC curve in machine learning with complete clarity, and we will use simple mathematics and clear numerical examples. We will also understand how the choice of threshold affects the model performance. Okay, so let us start from the beginning. So in binary classification, a machine learning model does not directly output a class like positive or negative. Okay, instead it outputs a probability, okay, between 0 and 1. Okay, so let us say that it can give you probability of zero point 0.7 or zero point 0.2, okay, between 0 and 1. So this probability represents how confident your model is that the sample belongs to the positive class. Okay, now to convert this probability into a class label, we choose a threshold. Okay, so let us say the threshold is given by t. Okay, so if the probability is greater than or equal to threshold, okay, it means the model is predicting positive class, and if your probability is less than threshold, it means your model is predicting negative class. Okay, so generally most beginners choose threshold to be zero point 0.5. Okay, but this value is not very special. So the moment we change the threshold, the predictions also gets changed. Okay, so the confusion matrix changes and all evaluation metrics will also get changed. So this is why we need a method that evaluates the model across all possible thresholds, not just this value 0.5. Okay, so that is why we need ROC curve. Okay, so before defining ROC curve, let us recall two important quantities from the confusion matrix, okay, which are true positive rate okay, and false positive rate. Right? So what is true positive rate? So true positive rate tells you that out of all actual positive cases, how many did the model correctly predict? Okay, so out of all actual positive cases, how many did the model correctly predict? Okay, so its formula is true positives divide by true positives plus false negatives. Okay, now the second quantity is false positive rate, okay, which tells you that out of all actual negative cases, how many wrong how many were wrongly predicted as positive. Okay, so out of all actual negative cases how many were wrongly predicted as positive. Okay, so its formula is false positives divided by false positives plus true negatives. Okay, so now based upon these two quantities, true positive rate and false positive rate, we can define the ROC curve. Okay, in which your x-axis is false positive rate, okay, and your y-axis is true positive rate. Okay, so the curve between true positive rate and false positive rate is ROC curve. Okay, so let's say we have a curve like this. Okay, and each point of that curve corresponds to one particular threshold. So let's say this point corresponds to threshold T1, this point corresponds to threshold T2. Okay, so now to understand the relation between true positive rate and false positive rate, we will consider one example. Okay, now in this example let us consider 5 samples. Okay, so let us consider sample A, okay, which is actually positive, and this is the predicted value, which is, let's say, 0.95. Okay, this is actual. Now for the second sample, the actual is 1 and the predicted is 0.8. For the third sample, the actual is 0, okay, and predicted value is 0.6. For the fourth sample, the actual is value 0 and predicted is 0.4, and for the fifth sample, the actual value is also 0 and predicted value is 0.1. Okay, so we have these 5 samples. Okay, now let us change the threshold step by step. Now first take threshold to be equal to 1. Okay, so since no probability is greater than or equal to 1, so all samples are predicted as negative. All samples are predicted as negative. Okay, so it means your true positive will be 0. Okay, your false negative will be 2. Okay, your false positive will also be 0, and your true negatives are 3. Okay, Now let us calculate TPR and FPR. So TPR is 0 divided by 2, okay, and FPR will be 0 divided by 3. So it is also 0, okay. So now we have now obtained the coordinates of our TPR and FPR, which is 0 comma 0, okay. So at threshold t equal to 1, we get this coordinate of our curve, okay. Now let us try to reduce the threshold value to 0.8, okay. So in this case, your sample A and sample B will be predicted as positive and rest of them will be predicted as negative, okay. So the true positive will be 2, okay. False negatives will be 0, false positive will also be 0, okay, and true negatives will be 3. So it means that your TPR is 2 by 2, okay, which is equal to 1. Your FPR will be equal to 0 by 3, which is also 0. So this gives us the coordinate 0 comma 1, okay, because FPR is 0 and TPR is 1. Now let us further reduce our threshold to 0.6, okay. Now in this case, your A, B and C will be predicted as positive, okay. So it will predict A, B and C as positive, but you can see that C is actually the negative, okay, its actual value is 0, so that it will predict wrongly, okay. So in this case, our true positive will be 2, our false positive will be 1, our true negative will be 2, okay. So accordingly our TPR will be 2 by 2, which is equal to 1, and FPR will be equal to 1 over 3. So now this will again give us a coordinate which is 1 over 3 comma 1, okay. Now let us further reduce our threshold to t equal to 0.4, okay. So when we will lower our threshold, so A, B, C and D will be predicted as positive, but C and D are actually negative, so we have two false positives, okay. So we have two true positives and two false positives, okay. Accordingly our TPR will be 1 and our FPR will be 2 by 3, okay, because we have one true negative in this case. So this will again give us one coordinate 2 by 3 comma 1, Okay. Now finally, let us take t equal to 0. So in this case, it will predict all samples as positive. So all samples are predicted as positives. Okay. So now we have true positives 2 and false positives 3, and therefore our TPR will be 1 and FPR will be also 1. Now if we plot these values in our ROC curve, okay, we will obtain a curve which is something like this. Okay, so as we reduce our threshold, the model becomes more aggressive in predicting the positive values, as we have seen. So it means that this increase in the true positive rate will also increase the false positive rate. Okay, so the ROC curve captures this trade-off, I mean, visually. So how we will compare how better is our model in predicting positive class or negative class? So for a random model, the actual curve is like this. It is almost a straight line. Okay. So now this diagonal line, it represents a random classifier. Okay. Random classifier. Now the closer your curve is to that diagonal, or let's say the closer the curve is to around this corner, the better your model is at separating between positive and negative cases. Okay, so to summarize, the ROC curve uses a single number, okay, which is the area under the curve, or AUC. So this is the area under the curve. Okay, we also call it AUC. Now based on this AUC, only on this particular number, it will tell us how better is our model in predicting the positive and negative class labels as compared to the random classifier. Okay, now which threshold is the best one among all the thresholds that we have chosen? So as we can see, the threshold zero point 0.8, it gives true positive rate equal to 1 and false positive rate equal to 0. Okay, so there are no false positives and no false negatives. So this is the best threshold that we have obtained. Okay, so based upon this threshold, we can identify the balance between the actual positives and actual negatives. Okay, so I hope you like this video. Thanks for the watch.